Welcome to our video over the Chapter 6 test practice. So number 1, use the information to solve the triangle. So remember, when we solve a triangle, we're looking for all missing side lengths and all missing angle measures. So I'm just going to draw triangle ABC. So little c is opposite of angle C, little b is opposite of angle B, and little a is opposite of angle A. So now we're going to go ahead and write what we know. We know that little a is equal to 6, c is equal to 43 degrees, b is equal to 24 degrees. So at this point, the easiest thing to do would be solve for a. Since we know that triangle sum is 180 degrees, I'll take 180 degrees, subtract 43 and 24 degrees. So I get 113 degrees for A. Now to find B and C, since we have side angle pairs, we know that's now 113 degrees. We can go ahead and use the law of sines. Now because this is obtuse, I know that B and C have to be acute. So I'm going to start with solving for B. So the sine of 113 degrees over 6 equals the sine of 24 degrees over the length B. So that means B equals 6 times the sine of 24 degrees divided by the sine of 113 degrees. So B is about 3.337. And then I'll go ahead and solve for C. So C is equal to 6 times the sine of 43 degrees divided by the sine of 113 degrees. And C is about 4.445. So here we have solved the triangle. Okay, find the area of the triangle having the indicated sides and angle. So little b equals 5 and c equals 9. Now, the book had some area formulas involving this side angle side case, and if you'd like to memorize those, you're more than welcome to. But I much prefer you just start with the formula you remember way back when, 1/2 base times height. So how would we find the height of that triangle? Well, looking at this triangle on the left, I have a hypotenuse of 9, and 35 degrees is opposite of the height. So the height is equal to 9 times the sine of 35 degrees. And I get about 5.162. So area equals 1/2 times the base, 5, times the height of about 5.162. And so the area is approximately 12.905 units squared. Okay, number 3. So here's our picture. So basically the airplane went 86 miles east. It turned northward at north 35 degrees east. So that little angle is 35 degrees. Then it went, when it was 137 miles from the airport, it realized that there was a problem and it turned around. So we're looking for this angle right here. Well, I know this part of the angle is 90, so this whole angle here is 125 degrees. So we have a side angle pair that we know, and we're going to look for this angle right here, which I'll call theta prime, in order to find the angle that we need to turn around. So using the law of sines, I know that the sine of 125 degrees over its opposite length of 137 equals the sine of that reference angle over 86. So sine of theta prime equals 86 times the sine of 125 degrees, all divided by 137. So now we use the arc sine. So I get about 30.9 degrees. So the angle that we need to turn around is going to be equal to 180 minus 30.9 degrees. Sorry. So 149.1. Okay, number 4. Use the law of sines to find the third side. So this would be little a. So we know that a squared equals b squared plus c squared minus 2bc times the cosine of a. So we'll go ahead and plug in what we know. We know that b is 4, c is 10, and angle A measures 54 degrees. Oops. So a squared is about 68.977. So we take the square root to find a. A is about 8.305. Okay, number 5, use the given measurements and the law of cosines to solve triangle ABC. So I'm going to go ahead and draw a picture of the triangle. So I know little a is 17, little b is 14, little c is 20. So when you're given 3 sides, my recommendation is to solve for the biggest side length. Solve for the biggest angle measure, because we know that the biggest angle measure is opposite of the biggest side. So we'll use the 1 involving c squared on the left side to solve for angle c. So 20 squared equals 17 squared plus 14 squared minus 2 times 17 times 14 times the cosine of c. Now, we really need to be careful at this point, because when we simplify, I've noticed that many students have been simplifying incorrectly. Now, this whole part is multiplied to cosine c, so we're not going to combine what we get here with this 2 times 17 times 14. We'll just go ahead and do 17 squared plus 14 squared, which gives us 485, minus 2 times 17 times 14 is 476 cosine c. So we'll subtract 485 from both sides. And we get negative 85 equals negative 476 cosine c. So the cosine of c is equal to 85 over 476. So c is the arc cosine of 85 over 476. And I get about 79.713 degrees. So at this point, I can use the law of sines to find either angle A or angle B. I'm just going to choose angle A. So the sine of 79.713 degrees, remember that's C, over 20 equals the sine of B over 14. So the sine of B equals 14 sine of 79.713 degrees divided by 20. Take the arc sine, and we get about 43.53 degrees. Now, the reason why I had you write a lot of decimals here is not because we really want our answer with that many digits of precision, but just so that when we do the equations, we have less error. At this point, it's